Hello guys, today we will talk about an important topic of the chemistry, that is the interpretation of FTIR, CNMR and NMR spectra for the 1,1-dichloroethane, iodoethane and 2-propanol. Actually, these spectra are very important in the BS, MSc, MS, SESS, CSIR and also in some other courses. So, we will talk about these spectra and it is very informative. We will talk about these, we will interpret these spectra. In this lecture, we will cover all the steps that is required to interpret these spectra. So, let's begin here. So, first of all, we will talk about the C2H5I. This is our molecular formula. Molecular formula is given and we will solve the C13 NMR and the proton NMR spectra from this molecular formula. And this is the molecular formula of iodoethane. Okay, so first of all, here in the IR spectrum, you will see that no peak is present here. No peak is given in the spectrum that we can circle and conclude that this functional group is present or that functional group is present. So it means that no functional group is present in our IR spectrum. So we will go to our C13 NMR spectrum. If you see here in C13 NMR spectrum, here it is given in the 50 MHz and the solution that we use is CdCl3. So CHCl3 is the formula of chloroform. It means that we are using the deuterated chloroform. So here two spectra are given. First is proton coupled spectrum and the second spectrum is proton decoupled spectrum. First of all, we will solve the proton coupled spectrum. Proton coupled spectrum is that spectrum where our proton is coupled with the C13, any isotope of the carbon 13, any isotope of the carbon that is carbon 13 present in our compound. So here you will see here 3 peaks. Okay, now if I tell you that 3 peaks means that there is 1 carbon plus 2 hydrogens are present. This is the meaning of the triplet. Similarly, if you see here, there is a 4 peaks, which means the quadrat. Quadrat means 4 peaks are present. Between these 4 peaks, 1 will be for carbon atom and plus the 3 other peaks representing the 3 hydrogen that is present, that is attached with the carbon atom. So, proton coupled spectrum tells us about how many hydrogens are directly attached with the carbon. So, this represents the CH2, means 2 hydrogen is directly attached with the carbon, and this peak represents the CH3. 1 peak for carbon and the 3 hydrogens are directly attached with the carbon. So, this representing the methyl group. So, now, with the help of proton coupled spectrum, we know that we have the CH2 group in our compound and CH3 group in our compound. Now, let's move to our proton decoupled spectrum. Here in this spectrum, you will see the 2 peaks. 1 peak is here. If you see this peak is just in the line of the peak that is representing the CH2 group in the proton coupled spectrum. And the other important thing in our spectra is the chemical shift value. Chemical shift value is almost at the 0 ppm value. And this value is falling in the range that our alkyl groups are present. So, we know from the proton coupled this is the CH2 group, yes. And the chemical shift value is also saying this is the CH2 group. And the other thing is that this CH2 group may be attached with some electron withdrawing group. So, this peak is just in the line of with the second peak of the proton coupled spectrum. This is for the CH3 group. And this peak shows us that the chemical shift value is for 10-20 ppm value. This 20 ppm value is showing the presence of the CH3 group. As the CH3 group is present, it concluded from the proton coupled spectrum. Okay, Then what is the advantage of the proton decoupled spectrum? Then all the information we are getting from the proton coupled spectrum. Actually, this proton decoupled spectrum is advantageous for us only when the carbon atom is present that is not directly attached with any hydrogen. It means the quaternary carbon. The carbon that is not attached with the hydrogen or present some other group or attached with some other groups. So, this proton couple will only tell us the carbon atoms that is directly attached with the hydrogen. And proton decoupled spectrum can also tell us about the carbon that is not directly attached with the hydrogen, like the C double bond O group. If the C double bond O group or any other group like the carbon that is quaternary carbon that is present in our structure, then the proton decoupled spectrum cannot detect it. Then we will get that information from the proton decoupled spectrum. That's how proton decoupled spectrum is important for us. Okay, now from the C13, the information that we get is that CH2 group is present in our compound and CH3 group is present in our compound. Okay, now proton NMR spectrum. And this is the first peak. It is almost in the range of 1.8 ppm value. I am writing here roughly. And this is our triplet. If the triplet is present, we will define from n+1 rule that how many hydrogens are present in the neighboring. You will see here that 2 hydrogens are present in our neighbor. So, if the 2 hydrogens are present in the neighbor, now we will know that CH2 group may be present in our neighbor with the hydrogen here. But how many hydrogens are present here? The problem is that this term is scale value, integration value. Integration value may be present in the digitalized form or it may be present in the form of the scale. If it is present in the form of scale, we will calculate it by the equation and I will give you the equation. Also, I have made the video for that. You may go to playlist and search for that. And this is the scale value. This scale value from this integration value, we know that here 3 hydrogens are present in our peak area. So it means this is the CH3 group. And this chemical sheet value is also, and now in this area the hydrogens are de-shielded by the electrons. That's why it gives us the ppm value at the high range, almost in the 3.2 ppm range. So this is our concluded structure that we get from this IR spectrum, C13 NMR spectrum and proton NMR spectrum. Now if you see here, we conclude that CH3 is attached with the CH2 and that is attached with the iodine. And this structure representing the presence of iodoethane in your iodoethane. So the structure of this molecular formula is iodoethane. C2H4Cl2. This is our second structure molecular. This is our second molecular formula. This is our second molecular formula, and from this formula now we will conclude the structure. We will interpret the IR spectrum, we will interpret the C13 NMR spectrum and the proton NMR spectrum to conclude the structure of this molecular formula. Here, first of all, in the IR spectrum, some peaks are given to you. One is 689 per centimeter frequency and the other one is 2989 per centimeter frequency. This representing the, if you come back to molecular formula, here if you see C2H4Cl2 means C, hydrogen, mean carbons, hydrogen and chlorine. These 3 atoms are present in your structure or molecular formula. So, In the IR, these values represent that either the C11C bandings are present here, or the halogen groups that is attached with the carbon, and that is representing, then the peaks here represents that either the C11C banding is present, means the double bond is present, and in the range of 1600 we are here seeing no peak. It means that C11C is not present. And the other thing that it represents is either the CX bond is present in your structure. Yes, it may be possibility now that CX bond is present, because the CC bond that also gives us the peak in the 1600 region, that is absent. So it may be possible CX bond is present. Okay, come back to here. 2989 per centimeter region. This region may represent that the OH group is present in your structure. This may be due to the OH structure, but the peak area is not that sharp for that, so it means that it is not present. And the other possibility is that CH stretching is present. But the CH stretching, we get the information about the CH stretching about the 3000 to 3200 per centimeter frequency, but it is 2889, almost close to the 3000. But it may be possible that the CH group is directly attached with some electron withdrawing group, with some electronegative group that is withdrawing the electron towards itself. So it may be possible if the halogen group are present, so it may be possible. So this tells us about the speed, tells us about the CH stretching vibrations. So now from this IR spectrum, we're getting the information that carbon, hydrogen and halogen groups are present. And our structure is also telling us the same thing. So this is our IR spectrum. And from this IR spectrum, you may conclude the structure if you know this thing. But the main structure that we conclude and sure about that this structure is present, that is the NMR spectroscopy, NMR spectrum. From the NMR spectrum, we can 100% sure that this structure is present, and then after that we may do some test to identify the structure, that the structure is either present or not. So, but the IR spectrum helps us a lot in also in finding the structure. Okay, now we will see the C13 NMR spectrum for the same compound. Here, this is the C13 NMR spectrum. The same spectra is given here as proton coupled spectrum and the proton decoupled spectrum. Proton coupled spectrum tells us about the hydrogens that is directly attached with the carbons. So, here, one peak is present here and the other peak is present here. One peak that is present here, this tells us that the quadrate is present. I have already told you that when the quadrate is present in the proton coupled spectrum, it is always like this, that this quadrate means that one carbon is present and the rest of the peaks will tell us how many hydrogens are present. 4 minus 1 peak for the carbon, if we minus the 1 from the have 4 peaks, if we minus the 1 peak for the carbon from these 4 peaks, we will get the 3 s peaks, and these 3 peaks are for the hydrogens. So it means here CH3 group is present in the proton coupled spectrum. CH3 group is present, and the other is 2 peaks is present. As you show, this peak is due to the solvent. So 2 peaks means one is for carbon and the other is for hydrogen. So, and the other group that is present and the other information that we are getting from the proton coupled spectrum is CH group is present. So now these 2 peaks is already only given in the proton coupled. So one is CH3 group is present and the other is CH group is present. Okay, proton decoupled spectrum. From the proton decoupled spectrum, we are also getting the 2 peaks, 1 peak for the solvent. 1 peak is in the range of, 1 peak is just in the line of the other peak, that is quadrate. So it means the CH3 group is present. We also no need for confirmation about the chemical shift value. But if you see the chemical shift value, this is saying that yes, alkyl group is present. It means that it is assuring us that yes, CH3 group is present. And the other peak is CH group, and it is coming in the range of about the 50 ppm, and it is coming in the range of 50, 60 and 70, almost 70 ppm value. almost 70 ppm value. So it means that this CH group is attached with some electron negative atom, with some electron withdrawing group that is withdrawing the electron towards itself and making our hydrocarbons de-shielding from the electrons. Okay, so it means that two groups are present here and one is CH3 and the other is CH, and the proton decoupled spectra we are not getting any other peak, so it means the quaternary carbon is absent. Quaternary carbon is absent. Only two carbons are present, and that is one carbon that is directly attached with this H3, 3 hydrogen atom, and the other carbon is directly attached with only one hydrogen atom. The information that we are getting from the proton coupled spectrum is this: either it is true or not. We will get this. We will get the conclusive evidence about it from the proton NMR spectrum. So here, this is the proton NMR spectrum of this compound. Here, one peak is here and the other peak is here. Two peaks are present here. Okay, I have given the integration value to this peak. This integration values is that 3. It means that 3 hydrogens are present here. Okay. Okay, now if you see it, it is a doublet. Doublet means in its neighbor only one hydrogen is present. Doublet means 2, so n plus 1 rule goes. If you follow the n plus 1 rule, you will get that the number of the neighboring hydrogen is 1. So, I will use the other pen to write the neighboring hydrogen, that is this. Okay, and the integration value is telling us 3 hydrogens are present here. Now, we just only talked about the splitting pattern and about the integration value. If you see now the chemical shift value, this is almost 2.1 ppm value. This 2.1 ppm value is showing that alkyl group is present like the CH3, CH2 or CH. Splitting integration value telling us that 3 hydrogens are present in this area. So it means that CH3 group is present in this P area. Okay, now the other peak, this is a very short peak, but this is the expansion you may see here. 4 peaks are present, it means the quadrant. Quadrant means 4. And by n plus 1 rules, you will know that in the neighboring, there are 3 hydrogens are present. So, I will write the neighboring hydrogens from this pointer that CH3 group or 3 hydrogens are present in its neighbor. And now, integration value is telling us that only one hydrogen is present here. This is the one hydrogen is present here, and the chemical shift value is coming at 5.9 ppm value. This value is not going to in the benzene ring value and also not going behind. So it means that here some functional group, that some electron withdrawing group is present. And which electron withdrawing group is present here? That is giving us the values here in this range. In this range, the values we get only when some kind of the halide groups are present here or strong electron withdrawing groups are present. But in the molecular formula, you have seen that 2 chlorine atoms are present here. So, now if you attach the 2 chlorine atom here, we can attach the 2 chlorine atom here, right? How? Because this carbon is attached with the one bond by the CH3 group and the other bond with this hydrogen atom. And the 2 valency is less than, and this can be attached with the chlorine. If we attach the 2 chlorine atom with the same hydrogen, then it is possible that it gives us the chemical shift value here in the range of 5.9 ppm value. But if only one chlorine atom is present here and one chlorine atom is present here, then we will get this structure, this type of this spectrum. No, then we cannot get this kind of this spectra. Actually, if I draw here for you, just for your understanding, that why we cannot attach the chlorine atom on either side. Why we are attaching it only one hydrogen? Actually, if we attach the chlorine atom on either side, then you will see here the symmetrical compound is present. So these hydrogens and these hydrogens will have the same chemical environment. And if it will have the same chemical environment, then we will get only one kind of the peak in the proton NMR spectrum, only one peak. Only one peak with the integration value of 4. But here we are getting the two different peaks. It means that on that one peak is for the CH3 and one is representing this CH that is directly attached with the 2 chlorine atom. So the structure that we are getting here is 1,1-dichloroethane. 1,1-dichloroethane. That is we are getting here. We will write here again CH3 CH that is directly attached with the chlorine. So this is the 1,1-dichloroethane. This is our third molecular formula and the last structure for this. And the last one also for this lecture. Here is C3H8 and O. One oxygen atom is present. It means in your molecule, in your structure. And how this oxygen atom is present is the it may be present in the form of C11O, it may be present in the form of OH group, or it may be present in the form of COC, right? So it may be possible that how it is present. But we can get this information from the IR spectrum. Either this function group is present, we can get this information from the C13 NMR spectrum. Either this function group is present, we can get this information like this from the proton NMR, from the IR, from the C13, that either this functional group is present. That's how the spectra, that's how the interpretation of spectra, it helps us. That's how they help us to find the molecule that is unknown to us, the structure of that molecule. So now the problem is C3H8O. Only the molecular formula is given. Now we will deduce the structure. We will elucidate the structure of this compound with the help of NMR spectroscopy. So first of all, we will see here the IR spectrum that is taken in the neat position. Okay, the IR spectrum that we are getting here, only this kind of the peak is present, 3,354 per centimeter frequency. The other peaks are not very important and not present. So if the sharp peak I see here, this is due to the CH separating. We have already talked that this peak all give us the information about this. And here we get the banding information about the CH banding vibrations type. And here also see banding vibrations. And now this 3,354 per centimeter region, which type of the group we are getting. And this is also not a sharp, this is some type of broad, narrow broad peak. It means that OH group is present. So now this is concluded that this O is present in the form of OH group. So it may be possible that alcohol is present. But OH group is also present in the carboxylic acid. But if you see here that only one oxygen is given, not two oxygen. So the possibility of finding of the oxygen in the form of the carboxyl group or in the form of the ketonic group is now ruled out. Only the OH group is present. Okay, from the C13 NMR spectrum, then how we will conclude that OH group is present from the C13 NMR spectrum? Can we get the evidence from the C13 NMR spectrum or not? Actually, the O group is attached with carbon. Right or not? Right. It is always present in the carbon. So from the chemical shift value, the carbon gives us the more chemical shift value where it is directly attached with the oxygen as compared to the carbons that is only attached with the carbons or the hydrogens. So that's how it helps us. C13 NMR spectrum can tell us that the carbon is attached with the some type of the electron withdrawing group. Okay, in the C13 NMR spectrum, the proton coupled spectrum and the proton decoupled, both type of the spectrum are given. And if you want to know that how these work, I have already told in the previous two spectra, we have talked about this in this lecture. So now there is peak area here. This is the quadrat. Quadrat means one carbon and the three hydrogens are present. We will solve it now here like this. And this is the doublet. Doublet means one carbon, one hydrogen is present. So the groups we have taken from the proton coupled spectrum. And now if we see here the chemical shift values, here the chemical shift value is coming in range of about almost 25 ppm value. If you say here, this is the not exact values that I am getting, just like in the range of 25 ppm value. So it means that CH3 group is present. Yes, it is concluded from this. And here the peak area that is here, it is almost in the range of 50, 60 and 63 ppm value. Now from this spectrum, we concluded that only two types of the carbons are present. One is CH and the other is in the form of CH3. And from the chemical shift value, we have also concluded that yes, these groups are present, and these groups are in the line of in the proton decoupled spectrum, where the protons are not coupled with the carbon. It is representing that only the two peaks are present that are in line with these two peak areas. So it means that no other type of the carbon, it means the carbon, quaternary carbon is absent. The carbon that is not directly attached with the hydrogen is absent. Only two types of the carbons are present. Okay, now it's time to solve the proton NMR spectrum. Okay, now the structure is somewhat complex here. Actually here it was 8, not 5. Now the structure is somewhat complex here, and we are not in the right mind to say that either we have information that we are getting from this is correct or not, how we will arrange our structure. But the proton NMR spectrum will help us to identify it. Here you see 1, 2, and this is the third one. 3 peaks are present. 3 peaks means 3 different types of the hydrogens are present. It means that 3 different types of the hydrogens are present in your structure that are chemically different. So this one peak, first of all, this peak, if you see in the expansion, it is representing the doublet. Doublet is present. If the doublet is present, D4 doublet is present, it means that only one hydrogen is present in its neighbor. N plus 1 rule, by N plus 1 rule, you will know that only one hydrogen is present in its neighbor. And this is representing the 6th hydrogen is present under this peak area. It means how we will arrange these 6 hydrogen atoms. We can arrange it like this: CH3 and CH3. And in its neighboring, it is attached with the one hydrogen only, like this. Either it is correct or not, we may conclude it from this. If you see here, this is almost 1.2 ppm value. So it may be possible here that the methyl group is present. If we talk about CH group or CH2 group, that 3 CH2 group may be present here. So yes, it may be possible, but how we will arrange 3 CH2 group like this, that only the one hydrogen is present here, when we have to arrange the other 2 hydrogens also. If we attach here CH2 group, here CH2 group, and here CH2 group, I can use the other pointer. Just wait. Like this. CH2 group is here, CH2 group is here, here CH2, and here CH2, and here CH2. Now the first of all, this only one hydrogen should be present in its neighbor. And the second thing is that now this should be attached with some, this should be attached with some kind of the other group, and this should be attached with some other kind of the group. But the problem is that in our structure, we have the C3H8O. Only this structure is present. Means only 3 carbons are present. Here if you see the CH3 group and the CH3 group and the C is attached, it is somehow possible. So the other structure that I just assumed is ruled out. The only structure that I write the first, that was the correct. So it means that only this structure is possible here. Now this is exchangeable with the D2O. It means that the OH group is present here, simply. And it is coming in the range of 1.9 almost ppm value. That is for the OH group. And this may be the NH group. NH groups are also exchangeable with the D2O, but the molecular formula, only the O is present. I am writing here the molecular formula. Again, H8O. So the OH group is present here, and this is the quadrate. See, you may see here in the expansion, sorry. This is not a quadrate. 1, if you see here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 peaks is present here. Oh. 7 is equal to n plus 1 rule. If you see here, 7 minus 1 n. It means in the neighbor, 6 hydrogens are present. Are these 6 hydrogens are present in its neighbor with the CH? Yes. 3 plus 3, 6. Yes, 6 hydrogens are present here. So it means that this is representing the CH2 groups that is in its neighbor attached with the 2 CH3 groups. So yes, now the R structure is concluded. And the other thing is the chemical shift values. That is almost in the 4.1 ppm value. This 4.1 ppm value showing us that it is attached some kind of the electron withdrawing group. Yes, it is attached with some kind of the electron withdrawing group or the OH group. And it is also showing that the OH group is present. This chemical shift value also showing that. So this is our respective structure that we are getting here. CH3 group that is attached with the CH. And this CH is also attached with CH3 and here with the OH group. So what is this structure? This is the structure of 2-propanol. This is the structure of 2-propanol. So, okay guys, this is the end of our lecture. If you like my videos, then please share my videos, subscribe my channel, and press the like and click the bell icon. Great. पता नहीं कितने